Okay, in the final two videos, I'm going to just introduce some basic ideas of two-sample inference. I'm going to keep it simple by assuming that all population SDs are known, so we'll always have the z-distribution. This topic is not very clearly done in the book, so I want to do a video about it. This is also the launching point for the next term of statistics, so if you pay attention here, then you'll get one step ahead of the game when the next term arrives. Our first example here is about fat content in donuts. The first difference that you'll probably notice is that now there are two different kinds of donut. Let's call Dunkin' Donuts population 1 and Krispy Kreme population 2. So everything has a little number next to it to indicate where it comes from. Anything with a little 1 next to it indicates Dunkin' Donuts. So mu sub 1 is the mean fat of all Dunkin' Donuts. X bar 1 is the sample mean of the Dunkin' Donuts, and etc. And anything with a little 2 next to it indicates Krispy Kreme. Okay, our goal here is to make the 95% confidence interval for mu1 minus mu2, or the difference between the means of Dunkin' Donuts and Krispy Kreme. We're going to use the distribution of the difference of the sample means. If you go back to the CLT video, then you'll see that the difference has a normal distribution with this mean and this standard deviation. Here's a very quick explanation. The sample mean of Dunkin' Donuts has this mean and this variance. The sample mean of Krispy Kreme has this mean and this variance. Remember that when you find the distribution of the difference, that you subtract the means but you add the variances. Go back and take a look at the CLT video if you've forgotten why. Confidence intervals begin with a statement about probability. Since this is a 95% confidence interval, I want the middle 95% of the z-distribution. We've done this before, and we know that z must be between plus and minus 1.96. That gives us the middle 95% of the z-distribution. We create z the usual way. Take the sample means, subtract the population means, and divide by the SD. Now I'm going to plug in all the information given in the question. The previous slide had the sample means, sample sizes, and population SDs. Just be careful, a common mistake is to confuse variance and SD. We were told that the SD of Dunkin' Donuts is 5, but the formula needs the variance, or SD squared. So don't forget to square your SDs. The only things that we don't know are the population means mu1 and mu2. After solving, we get this inequality, and this is the 95% confidence interval for the difference in the means. Let's interpret this interval. Since this is Dunkin' Donuts minus Krispy Kreme, we can say that the average Dunkin' Donut has between 0.61 grams and 5.39 grams more fat than the average Krispy Kreme donut, with 95% confidence. The algebra for the interval again boils down to a pretty simple formula. The center of the interval is the difference in the sample means. And from the center, you go plus and minus a half width that is equal to a z value times the SD. The pattern is very familiar to simpler confidence intervals that we've done in the past. Now we're going to use the same setting but I want to do a different kind of question. This time I want to do a sample size question. We know from previous examples that these questions are all about the half-width of the interval. If the difference in sample means is within 0.5 of the difference in population means, then the half-width must be set equal to 0.5. The question says that we want 99% confidence, so we need the middle 99% of the z distribution. We know this happens when z is equal to plus or minus 2.576. So that is our z value. The population SDs were already given before. And this problem says that the two sample sizes will be equal. So I'm going to drop the subscripts since they are both the same. Solving for n and rounding up, we get 1,089. And let me be clear, this is the sample size for each population. So there are 1,089 Dunkin' Donuts and 1,089 Krispy Kreme donuts, which is a lot of donuts. Okay, here's a question about American versus European SAT scores. And in this question, we are given the confidence interval, and we need to work backward to figure out the confidence level. It's not written, but in this problem, population 1 was American scores, and population 2 was European scores. The first thing we need to do is figure out the center of the interval. Remember that the center is the difference in the sample means. And since the difference was negative, that actually means the European sample mean was 15 points higher than the American sample mean. That's not really required to solve this problem, but it's an interesting bit of information. What is required to solve this problem is the half-width of the interval. Since the center of the interval is negative 15, the half-width is 26.46. We were given all of these numbers in the question. Plug them in and solve for z. After solving, you'll get that z equals 1.96. We've seen this number before. We know that the area between plus and minus 1.96 is 0.95. So that means that we have 95% confidence. Just remember that when you do two sample problems, many of the same patterns apply. You still create z by subtracting the mean and dividing by the SD. The difference is now that the mean and SD are messier than before, but it doesn't change the overall approach to the problem. Okay, you now have 3 problems to do on your own. Good luck with that, and check out the next video.